Hi girls, so this video is just going to be about some properties of definite integrals. So I'm just going to run through some of the properties and attempt to explain why they work. And then in our next lesson, hopefully we're going to spend the whole time doing examples. So the first one I want to talk about is one that you've hopefully seen before. So a to b of f of x dx. And the property is that I can write this as negative b to a f of x dx. Okay, and the reason this works is that if I were to evaluate the left-hand side, this would give me capital F, whatever the integral is, of little f, of b minus capital F of a. And I could do the same thing on the other side, ignore the minus sign for the second, and this would be capital F of a minus capital F of b. And hopefully it's moderately obvious that those two sides should be equal. Oops, sorry, still learning. Not sure how to move the screen. Anyway, so that's the first property. Okay. The next property involves even functions only. So I'm going to draw a graph of some even function, and I'm just going to default to my standard parabola. Or something like it. And then the integral we're concerned with is this one, the integral from minus a to a of fx for even f. Okay, so if I just effectively randomly pick some values for a, so let's say that a is over here, so minus a must be over there. And now let's think about the area under that curve, right? Because that's what integrals are, area under a curve. So it is this area here plus this area here. And is it obvious that those are the same area, right? It's an even function, so that the function value for negative x is the same as the function value for positive x, and the area should be the same. And then I've also got this area under here plus, I know it's a negative, but adding negative areas, this area over here. And again, hopefully it's obvious that those two are equal. So, oops, let me rub that out. So we can say that this integral here is the same as, just look at the integral on the right hand side. If I just think about the integral on the right hand side, we kind of just showed there that all the areas on the right were the same as all the areas on the left. So I'll just take the integral on the right hand side and double it. The main reason that's powerful is because when I do the integration, if I can sub in f of a and I can sub in f of 0, and generally subbing in f of 0 is easy. So that's the main reason it's powerful. So that's the even function results. Next step, hopefully, is what about odd functions? So again, let me draw an odd function over here. Excuse the lack of arrows on my number line plane and that. So let's just draw some odd function. So remember, odd functions are rotated 180 degrees around the origin, so it just has to be some function that passes through the origin and roughly looks the same on either side. That doesn't look very good, but whatever. We all know what an odd function is. So again, I'm going to think about the same integral. So I'm going to think about the integral from minus a to a fx dx. And again, I'll pick some value for a. This time I'll pick inside here. And I'd like you to spend your time thinking about, is what I'm about to say still accurate if I picked, a over here, for example, or right near the origin or something? Are they all the same? So think about that. But again, let's think about the integral in terms of areas. So on the left-hand side, I've got this area, and on the right-hand side, I've got this area. And they're the same, right? It doesn't look very good, not the greatest drawing I've ever done, but symmetry tells me that those areas need to be exactly the same. One's above the one is above the x-axis, one's below. So you've got the same area in magnitude, but on the left is positive, on the right is negative. When you add them together, you get 0. That's a really powerful result, right? Obviously, if I can look at an integral and immediately say it's 0, that is something that I want to be able to do. It saves me a hell of a lot of time. Next one. So the next one is just a standard integral that I think it's worthwhile seeing. Is that the integral from minus a to a of the square root of a squared minus x squared dx. Let's draw a diagram. What is that? Correct. I hope you said a semicircle. And it's the area under the semicircle, which is the area of a semicircle, so it's half pi r squared, where r is a, squared. Okay, that's a standard integral that I'd like you to kind of keep in the back of your mind, because again, it can be very useful at times. Now, last one. So this is a standard trick that does come up quite a lot. And I'm just going to write it down, and then I'm going to attempt to explain why. So the integral f of x dx from 0 to a equals the integral, again from 0 to a, of f of a minus x dx. And again, you'll hopefully have noticed by now that all of these I'm explaining with area under a curve. So I'm just going to draw any curve. It doesn't say anything about oddness or evenness. So I'm just going to draw a non-even parabola for the sake of drawing it. And you may have to do some visualizing because my graph is not going to be brilliant. But let's put in a now. What colour do I want? Purple? Correct. So there's a. Right, so the area I'm talking about is this area here. Now, let's see if I can undo that and go from there. So that's the area I'm talking about. So I'm going to get rid of those now. So that's the left-hand integral that I just drew for you. So now for the one on the right-hand side, let's pick a new colour. So f of a minus x. So the first thing I want you to imagine is what happens with the minus x. Well, that's just going to reflect in the x-axis, right? So I've just got a mirror down the x-axis, and so it will look something like this. And that I should have met that point there. I hope you can tell. I hope you can realise why I should have done that. Okay, so that was the first step that I should have done. And then I'm going to move that to the right a units. Okay, so I'm going to flip it and I'm going to move it to the right a units. So hopefully you can see from that I just get exactly the same curve. Yeah? So the alternative is to say, well, the bits that are going to land between 0 and a, after I move it to the right, are now the bits that are between minus a and 0. Okay. Hopefully that makes sense. If it doesn't, let me know in the next lesson. But these bits down here that I'm now highlighting green, those are going to be the things that when I shift this function to the right a units, are going to land between 0 and a. And so that's going to be the integral that I had before. And hopefully it's obvious that this area is exactly the same as the orange area that I had a minute ago. Okay, that's quite a tricky result and quite a deep result. It's a very standard question, and I'll show you some types of questions in the next lesson that it uses for, but that's just worth knowing for all your exams from here on out. Alright, hopefully that was helpful. I'll see you on Monday.